Hello everyone. Good evening. Welcome to Dr. Ravi's Academy. In today's class, you will be understanding the concept of movement of a couple of engineering mechanics subject. To understand this concept, let us look at the rigid body. I have considered a rigid body is a steering wheel. As you know, when you are negotiating steering wheel to the left turn, you are supposed to apply the forces of F and F. Both are oppositely directed and separated by some distance, and this leads to you are rotating that in anti-clockwise direction. So this is anti-clockwise movement. The moment contributed is anti-clockwise. And if you want to negotiate a right turn, so you are applying oppositely directed two forces F and F. Both are equal in magnitude, oppositely directed and separated by some distance d, and this contributes clockwise movement. This is clockwise movement. That means you have two types of couples, clockwise as well as anti-clockwise couples, depending upon the direction of the forces are acting. And if you see that the sum of the forces will be zero, so there is no translatory effect of this particular couple. So now you can define the magnitude of the couple. The symbol used for this is, let us say, M. M is the symbol, and you are using C for the couple, and whose magnitude is the force multiplied by the perpendicular distance, that is known as moment arm, is d, F into d. So in first case it is anti-clockwise, so this direction is anti-clockwise, and in second case the moment of the couple, that is also equal in magnitude, both F and d, it remains same, only the change is it is clockwise, the turning effect is clockwise. So here it is anti-clockwise and here it is clockwise. So you have two types of movements, and observe carefully here. This leads to only turning effect. The tendency of the body is the rigid body is purely rotation. So there is no translatory effect. That you can conclude that it will be having pure rotation. The tendency is pure rotation. This is one conclusion you can understand. There is no translatory force in this. Some of the forces will be zero, and the body will experience only the tendency is rotation. Either it may be anti-clockwise or it may be clockwise, depending upon the direction of the forces you applied. And let us understand, let us consider a rigid body, and it is subjected to, of course, to forces of oppositely directed and separated by some distance. Let us say this is the distance d. The distance between these two is d, and this is let us say point A, and this is point B. I am considering another point C at a distance A from the this particular force. Yes, I have located 3 points. One point A is on left side force, which is pointing upwards, and I have considered another force, that is force F, which is acting downwards, and that is point B on this, and at a distance, at some distance A from this particular point B, as point C I have considered. Now I would like to write the expression for the moment of force about all these 3 points. Let us write down the sum of the moments about point A. So this is your reference point. So force F is contributing clockwise turning effect, force multiplied by momentum, and it is F into D. This is clockwise. You can denote it by clockwise as positive we are treating, right? So that is about A. And let us consider the moment sum about point B. Point B is lying on this force. About this particular force is having a tendency again clockwise only, F into the momentum D. That is also, clockwise. That is, you can treat that it is positive. And lastly, let us write down the moment sum about point C. That is sigma mc is equals to, this is the moment center. Now let us see that your left side force that is pointing upwards is at a distance d plus a, F into d plus a, and which is contributing clockwise. Clockwise you are treating positive, so this is positive. And the other force which is about c, this force is downwards and which contributes anti-clockwise turning effect, anti-clockwise. So anti-clockwise is minus F into, and the distance is moment arm is a. And if we expand here, FD plus FA minus FA, and FA gets cancelled and you have FD, same magnitude. In all the cases you have, if you take the momentum about point A, or if you take the momentum about point B, or if you take momentum about point C, which is at a distance A from this point B, or in general, if you write momentum about any point on the body, so the moment will be same. That means the moment of the couple is independent of the moment center. Your second conclusion is moment of couple is independent of moment center. I'm calling it as MC. So your moment of the couple, that is MC value, is, that is the reason, observe carefully, you need not take a subscript. Usually moment of a force you are going to use subscript, that indicates your moment center. Your moment of the couple is independent of the moment center. So you can understand you have two conclusions in this particular analysis, in this particular concept. One is it tends to rotate the body, pure rotation. There is no translatory effect of a couple. And second is the moment of a couple is independent of the moment center. That means you can indicate that moment of the couple at any point. You can write down MC, or you can indicate only the sense of rotation. You have to maintain that in the same sense, that is clockwise turning effect. Only the clockwise turning effect, at any point you can indicate it is MC within the rigid body, and it is because it is independent of the moment center. Thank you for watching this video.